Hello everyone. In the previous lecture of function, we have learned that the function can call itself also. Now this kind of situation when the function is calling itself is called recursion. So if we go by the definition, then a function calling itself is called a recursive function, and a function calling itself, that phenomenon is called recursion. Now, each and every recursion should have at least one base condition or the base case or the terminating condition. Now, if there is no base condition or the terminating condition, then what will happen that the function calling itself, this thing will be executed infinite numbers of time. To stop that one, we are going to put the base condition. So each and every recursion must have at least one base case or a terminating condition. Now, as we all know that the function is implemented using stack, so similarly the recursion will be implemented using the stack. Now, when we are going to use a recursion to perform a repetitive work, we are going to use recursion. Now the question arises, the iterative statement like for loop or while loop or do while loop performs the same repetitive task. So why we go for recursion? The thing is that using recursion, some of the complex problems which are very complicated to be performed using the iterative statement became very simple. Basically, the problems which we can perform by dividing into smaller tasks, then using that result of the smaller tasks to get the final result, that kind of operations can be easily done by the recursion function, which will be complicated to implement using the iterative statement. This kind of tasks where we can divide a bigger task into smaller tasks, then into another sub-knowledge task, these kind of operations are called divide and conquer method. When you have implemented the binary searching, that is also a divide and conquer method. Now let us check the basic structure of a recursive function. A recursive function means a function call itself. So you can see that here the recurse function is calling itself. So the first call is done by the recurse to the recurse function is done by the main function. So when it comes to the called function, the recurse function itself is calling the recurse function. So this situation is called a recursion, and a base condition or the terminating condition will be there so that the process does not continue for infinite number of time. Now we are going to understand the recursion with some simple examples. In the first problem, in the first example, the problem statement goes like, shows the first n consecutive integers in descending order. So we can do it using the for loop very easily or any other iterative statement very easily. But here, to understand the concept of recursion, we are going to implement using recursion. So suppose the value here, the main function is calling the show function with the value a. A is the numbers of terms we are going to print. A is the numbers of terms we are going to print. So if a is equals to 5, then my output should be a 5 4 3 2 1 using the recursive function. To understand a recursive function or a recursion, the best way is to use a recursive tree. Now, what is basically a tree? Tree had branches and recursion have branches. So, to understand that one, we are going to use a tree-like of structure where there will be branches, and we are going to call that as a recursive tree. So let us take the main function is calling the show function. We are going to represent the show function by the function s. So the main function is calling the s function with the value 5. Now what is happening? The value 5 will be copied into x. X is the formal argument and the 5 is the actual argument. So actual argument will be copied into x and that will be used in the show function. So in show function what we are doing, we are first checking that x is greater than 0 or not. So now x value is 5, so it is obviously greater than 0. As it is greater than 0, so it will enter into the if block. Now in the if block, what is the first function it is, first operation it is performing? It is printing the value of x. So it will print the current value of x, that is 5. Then what is happening? Then show function is calling itself, but here it is passing the parameter x minus 1. So x minus 1 means what is the current value of x now? It is 5. So 5 minus 1 is 4. So show function will call itself with the parameter 4. So here it will get x value will be 4, and as x value is greater than 0, so once again it will print the value of x, which is now 4. Then it will call itself with x minus 1. What is the current value of x minus 1? That is 4 minus 1, 3. So now this function will call itself with the parameter 3. So here x value in the current state will be 3, and remember, as the function calling will be done using the stack, each and every parameters are put into the stack of that function. So each and every function from main to s, this s, this s and this s are maintaining their stack. So x value is now, current value is x is now 3, 3 is greater than 0, so it will call itself with the x minus 1, that is 3 minus 1, 2. So x2 will be called. Then as value of x is greater than 2, because current value of x is 2, so 2 is greater than 0, so it will first, in this case it will print 3, then it will print 2, then it will call itself with the value x minus 1, that is 2 minus 1 s1. So it will call here the x value will be 1, as x value is greater than 0, so it will print the current value of x, that is 1. Now it will call the show function. This s1 will call itself, but here the parameter will be x minus 1, that is 1 minus 1, 0. So it will call itself with s with the value 0. Now as x value is 0, so the if condition will be false. Now for s0, when the parameter is 0, the if condition is false, so the statement within the if statement will not be executed, so it will come to this point. Now as there, from here it will go back to its calling function. So for s0 instance, what is the calling function? It will go back to the s1. Now from s1, where it will come back? It will come back to the next operation to be performed, as there is nothing to be performed in we have left the S1 at this position, and after that there is nothing to be performed, so S1 will be returned to its calling function, which is S2. Now in S2 we have left at this position, so there is nothing to be done in the S2, so it will go back to its calling function, that is S3. Now S3 we have left in this position, there is nothing left to be done in S3, so it will go back to its calling function S4. S4 also we have left here, so from here there is nothing left to be done, so it will go back to its calling function, that is S5. And finally S5, we have left S5 at this position, so it will go back to its calling function to the main function. So in the main function it will go back to this return statement, and main function will return the 0 value to its calling function, that is the operating system. So we have printed the in consecutive integer numbers in a descending order or in a reverse order. Now, if the problem statement is like that, show the first n consecutive integer number in ascending order. You can see that the change we have made there, the show function is executed before the printf statement. So let us take the main function is calling the show function with the value 5. So a value is 5. So this a value will be called, the main function will call s5. Now in s5 x greater than 0, obviously because s value is 5. So first here, without printing anything, it will call itself, but the parameter will be s4. Then x value is greater than 0, so it will call itself with 4 minus 1, that is s3. Then s show 3 will call itself with the parameter x minus 1, that is 3 minus 1 2, so s2. Then s2 will be called with the parameter s1, and finally s1 will call itself with the parameter 0. So as in this case the x value is becoming 0, so this condition, this is the base condition, is false. So what will happen is that it will going to perform the next task. So what is the next task? As this there is nothing to do, it will go back to the calling function s1. So in the s1, where we have left at this position. Is there any task to be done in the calling function where the parameter value is x? Yes, we have to print that one, print the value of x. What is the current value of x now? For s1, the current value of x is 1, so it will simply print 1. Then there is nothing to be done, so it will go back to its calling function s2. So in s2, where we have left with this function calling, so there the next statement to be performed is the printing of the value of x. So in case of x2, the value of x is 2, so it will print 2. Next, there is nothing to be done, so it will go back to its calling function s3, and we have left s3 at this position, so it will perform the next statement. So printing of 3 will be done. As 3 value is x value is 3, so it will print 3. Then it will go back to its calling function, that is s4, and s4 we have left at this position. So in s4 we have left at this position, so it will perform the next statement, the printing of value of x, where x value is now 4. Then it will go back to its calling function s5, and here the x here we have left in this position, so it will perform the next statement, that is the printf statement, where it will printing the value of x, so it will print the value of x, that is 5 in case of s5. Finally, S5, from S5 it will go back to the main statement, main function, and in the main function it will return the 0 value to the OS. You can see that by changing the order of the function calling and the printing statement, we have we are getting a completely different result. So this is to give you the idea of the recursion. We are going for another example where we are going to calculate the factorial of a number. Here what we are going to do, the fact function, which is a user defined function, will be called from the main function, and that will calculate the factorial and return that value to the main function. So as we know that the factorial is basically on the work on the integer, and a factorial value is an integer. So the function return type is integer, and it is taking a integer as an input argument. Now here we are the printf statement will be like, suppose the a value is 5, so it will print factorial 5 is equals to 120 if my code is correct, or if I have logically implemented that one. So the user is giving the value for a, and we are calling the fact function with the actual argument, which is a, and that actual argument will be copied into a. You can see that there are two return statements, and this condition is called, will be my base case or the terminating condition. So let us take the main function is calling the fact function with the value 0, and we know that the factorial of 0 is 1. So what will happen over here is that the f will get 0 value. As f is 0, then this condition is true. So the fact 0, when we are calling that one, it will return the value 1 to the main function. So it will return 1 value to the main function, and that will be stored in B. So it will show factorial of 0 is equals to 1. Right? Now next, suppose the main function is calling the fact function with the parameter 1. So a value is 1, that will be copied into f. As f value is 1, so this condition will be true. As it is true, so it will simply return the value to the calling function. Here the calling function is the main function, so it will return the value 1 to the main function, and b will get 1 value. So it will show factorial of 1 is equals to 1. For a bigger number, suppose the a value is given by the user is 4, then the main function will call the fact function with the parameter 4. So this 4 will be copied into f. Now as this if condition is false, because f value is neither 0 nor 1, then it will go to the else part and return f into fact f minus 1. Here it is calling itself, so it is a recursive function and there is a recursive call. Now so it will call itself with the value f minus 1, that is f3, and it will return the value to its calling function. So it will return what value? F into f3. Now f3, here the f value will become 3, and as it is not satisfying this if condition, so it will go to the else part and it will call itself with the parameter f minus 1, that is 3 minus 1 2. So it will call itself with the parameter 2. Now this function will return this value to its calling function, that is the f4 function, with the parameter, return the parameter f into f minus 1, that is 3 into f2. Then f2 function, now the f value will become 2, and as the if condition is false, so it will call itself with the parameter f1, and this f2 function will return to its calling function, that is the f3 function, the parameter 2, that is the value of f into f1. So this statement. Then the f1 function is called and the current value is f is 1. So as f value is 1, so this condition is satisfied, and as this condition is satisfied, the f1 function will return the value 1 to its calling function. So I will get the f2 will have the value 1 as return value by f1. And where it will use this f1 value, it will use this f1 value at the return statement. So it will f1 will be replaced by 1, so it will give you 2. Now this value 2 will be returned to the f2's calling function. And which one is this? The f3. So f3, here we will get 3 into f2 means the value returned by f2, that is 2. So if 3 will return 6 value to its calling function, which is the f4. So f4 will get the value 6 for this statement. So it will become 4 into 6, that is 24. And this 24 value will be returned to the main statement, main function. So in main function, the value 24 will be stored in the variable b. So if a value is 4, the output will be factorial 4 is equals to 24. So what is the logic of calculating the factorial? This is the same logic we do in the mathematics. In mathematics, what we do? 5 into factorial 4. Then factorial 4 is 5 into 4 into factorial 3. Then factorial 3 is 5 into 4 into 3 into factorial 2. Then factorial 2 is 5 into 4 into 3 into 2 into factorial 1, which is finally 1. So this way we calculate the factorial in mathematics, and this code or recursive code for the factorial is implementing that same logic to calculate the factorial of a number n. Next part of this video, we are going to discuss more about recursion with 3 more examples. Then we are going to run all of the 6 codes which we have explained in this discussion of recursion. Till then, stay safe and thank you for watching this video.